Alright, so let's take a look at worksheet problem number 7 here. So this problem kind of incorporates the bulk of everything we learned in chapter 11 here. So what you're given is you're given a chemical reaction between sodium bicarbonate, which is NaHCO3, and citric acid. So sodium bicarbonate is found in a lot of different antacids, and one thing it can do is it can neutralize citric acid, and one of the products from this is carbon dioxide. So you're given a balanced chemical equation, and in the first question, part A, you're asked to determine which reactant is limiting. So you determine what your limiting reactant is by comparing what you have to the ratio, the mole ratio, in the balanced reaction. So we're going to compare mole ratio of what we have to mole ratio in balanced reaction. We're not going to do this using masses, so what we need to do is we need to take the masses we're given. We're told that we have 1 gram of sodium bicarbonate, and 1 gram of citric acid. We need to take these masses and we need to convert them to moles. So you can do this using the molar mass for each one. So we just need to make sure our units work out. In this case, we're dividing by the molar mass so that we cancel out our grams. Like so. Do that for each of them and you'll end up with 0.0119 moles of sodium bicarbonate and 0.0052 moles of citric acid. Your balanced reaction tells you that each mole of citric acid will react with 3 moles of sodium bicarbonate. We want to know if we have too much sodium bicarbonate or too little sodium bicarbonate. So if we want to know how much NaHCO3 we have per citric acid, what we're going to do is we're going to divide the number of NaHCO3 moles by the number of citric acid moles that we have. If you do that, you get 2.29. If we want to put that in ratio form, right, what this 2.29 tells us is that for each mole of citric acid, we have 2.29 moles of NaHCO3. Let's compare that to the balanced reaction. Okay, our second number is less than the number in the balanced reaction. That indicates that we have too little sodium bicarbonate. If we have too little sodium bicarbonate, our sodium bicarbonate is limiting. So that's the answer to part A. Now in part B, you're asked how many grams of carbon dioxide will be produced by this reaction. Our first step is already done for us in part A. We're asked to determine what our limiting reactant is. So we need to use our limiting reactant to determine how much product is going to be formed here. And what makes our lives even easier is that in part A, we also determine the number of moles of our limiting reactant. Right? We did that to figure out which reactant was limiting in the first place. What we can do now is we can go from moles of our limiting reactant to moles of our product, and from moles of our product to grams of our product. You use the mole ratio to go from moles to moles, and you use molar mass to go from moles to grams. So if we look at our balanced chemical reaction, it says that 3 moles of CO2 will be produced for every mole of sodium bicarbonate that is consumed. So in our first step, we multiply the number of moles of sodium bicarbonate, which again is our limiting reactant, by that mole ratio. We cancel out our moles of sodium bicarbonate to give the number of moles of CO2 that will be produced. If we then want to get grams of CO2, we take the number of moles of CO2 and multiply it by the molar mass. This allows our moles to cancel out, and you end up with 0.524 grams of CO2. In part C, we're asked how much of our excess reactant is left over. So what we need to know to solve this are a few things. Right? We need to know how much of our total excess reactant we had to start off with. We need to know how much of it reacted, because the law of conservation of mass tells us that the total amount of excess reactant is equal to the amount that reacted plus the amount that's left over, what we'll call the excess. We're given the total. Right? The total is 1.0 grams. We can solve for the amount that reacted using our balanced chemical equation in our number of moles of our limiting reactant. So again, we determine those number of moles back in part A. Sodium bicarbonate is our limiting reactant. We start off with 0.0119 moles of it. We can figure out how many moles of citric acid reacted using the mole ratio from the reaction. So the reaction tells us that for every 3 moles of NaHCO3 that you have, 1 mole of citric acid will react. So we use that mole ratio to cancel out our moles of sodium bicarbonate. If we stopped here, we'd have the number of moles of citric acid that reacted. I want to go one step further and get the mass of citric acid that reacted, so you do this using the molar mass. In this case, we're multiplying by molar mass because we want to cancel out moles and get grams. So you end up getting 0.762 grams of citric acid that reacted. Okay, as we said earlier, our total mass is equal to our mass that reacted plus our excess mass. We can rearrange that equation, and we can subtract the amount that reacted from our total. Doing so will yield our excess mass. 0.238 grams of citric acid are left over. In the last part of problem 7, we're told that our actual yield from this reaction is 0.487 grams, and we want to know what the percent yield is. Okay, the key to this is just remembering the formula for percent yield. That's actual divided by theoretical times 100%. Theoretical is the amount of your product that you're supposed to get. Actual is the amount that you actually get. In a problem, you're usually given the amount of actual yield, and you're supposed to calculate the theoretical yield. Luckily for us, we calculated that theoretical yield back in step B. We're supposed to get 0.524 grams of CO2 based on the amount of reactants we have. So that's what goes in the denominator here. In the numerator, we put our actual yield. Again, that's what we're given. Multiply it by 100. You end up with 92.9% yield for this process.